multiplying polynomials. Some of this will seem fairly straightforward to you, as we have seen quite a bit of it in our exponents unit. By the end of class today, your goals are to be able to multiply a monomial by a monomial concretely and pictorially, and pick a strategy that works best for you to multiply. So we're going to be doing it both symbolically and pictorially using algebra tiles. So like I said, a lot of this we covered in our exponent unit, so let's go through and remember our rules. So in our exponent unit, we talked about multiplying something with the same base. So here we have an example where we have x squared times x to the power of 4. So just a reminder, when you have the same base, you add the exponents. Alright, so let's try it. X squared times x to the power of 5 becomes x to the power of 2 plus 5, which is just equal to x to the power of 7. So the only thing that gets a little more complicated is when we have coefficients in there as well. So if we have coefficients, we still multiply them. You don't add the coefficients. So for example, we have 2x squared times 8x to the power of 5. We multiply 2 times 8, which is 16, and then we take our x's and we put them together for x to the power of 2 times x to the power of 5, and we can add those exponents. So it's going to become 16x to the 7th. Alright, so let's go ahead and try multiplying these. If you're feeling confident, you can go ahead and do them on your own and pause the video. If not, you can listen to me. Okay, so you can, if you want, group your like terms, as we would call them, although technically they're not like terms because they don't have the same exponent. But if I wanted, I could rewrite this as 7 times 2. Oh, my pen's not working very well. Let's try that again. 7 times 2 times x times y to the 3 times y to the 5. Now I can see that I need to take the 7 and multiply it by the 2, which is 14. The x, there's only one of them, so I can leave it the same. And then for y to the 3rd times y to the 5th, we can add the exponent for y to the 8th. So my simplified answer is 14x y to the 8th. So now what happens if we have negatives? We use our integer law. So I'm going to rewrite this as negative 2 times negative 5, collecting my coefficients. Then I'm going to multiply my s's, s squared times s to the 4th, and then I'm going to multiply my t's, t to the 3rd times t to the 2. Okay, so negative 2 times negative 5, and negative times a negative is a positive 10. S squared times s to the 4th gives me s to the 6, adding those exponents, and t to the 3rd times t to the 2 gives me t to the 5th. Alright, pause the video and try the next ones on your own, please. Alright, here are the answers for the next two questions. Remember that if you have a negative in front of your x squared, as in that second example there, that the x is part of the base of the exponent, but because that negative sign is not part of the base, it can actually be counted as a negative 1. So my coefficients in that example are negative 1 times 2 times negative 2. So negative 1 times 2 is negative 2. And then negative 2 times negative 2 is positive 4. Alright, let's move on to our next example. This is also a review. It's power of a power. So remember, when we have power of a power law, we can multiply the outside power by the inside powers. So you have to remember that everything on the inside has to take the outside power into account. So for the first example, the 2 needs to take the outside power into account. So you could rewrite this as 2 to the power 1, a to the 3, all to the power of 2. And then that 2 needs to be multiplied by every exponent. So 2 to the power of 2 times a to the power of 6. So the 1 was multiplied by the 2, then the 3 was multiplied by the 2. We can simplify this to 4a to the 6th. So a to the 6 is in simplest form because we don't know what that variable is. Alright, let's go ahead and try the next one. So reminder that negative 5 needs to get to the power of 3 applied to it as well. And that doesn't mean negative 5 times 3, it means negative 5 to the power of 3. And the negative 5 needs to be in brackets. We're going to have a to the power of 6 because of 2 times 3. B to the power of 3, because if you'll remember, B has an invisible 1 there, so the 1 needs to be multiplied by the 3, and C to the power of 12. Now we can simplify this just a little bit. We have negative 5 to the power of 3 in brackets, which means that negative 5 times negative 5 is 25, and 25 times negative 5 gives me negative 125, while my variables and their exponents are going to stay the same. And that is in simplest form. Alright, go ahead and try the next two, see how much simplifying you can do, especially in that second example. Pause the video. Alright, let's check your answers. I got 32, x to the 5th, y to the 10th, z to the 25th. And for the second one, I'm not quite finished. I hope you guys all got to this step, but we're not simplified now. We can go back to our product rule, which says that we multiply the coefficients. So I need to type in 27 times 4 on my calculator, or do it in my head. 27 times 4 is 108. I need to add the exponents on my x's and add the exponents on my y's. So my simplified answer is 108, x to the 4th, y to the 8th. Alright, so what happens if we want to use algebra tiles to represent it? Or maybe even we just want to calculate the area of something, including variables. So keep in mind that the area of a rectangle is just area equals your length times your width. So I have two rectangles here that we need to calculate the area for. So I have 4x cubed times 2x4. So my area equals 4x cubed times 2x to the 4th. Now we just use our knowledge of multiplying. We multiply the coefficients, 8, and we use our product law to add the exponents, x to the power of 7. So a simplified version of my area is 8x to the 7th. Let's try it for the second one. My area is equal to my length times my width, so 3x squared times 12y to the 8th. Alright, so we can do the same thing. We have 3 times 12. So 12 times 2 is 24, plus another 12 is 36. And then I have x squared y to 8th. Can I use my exponent laws on this? No, I cannot, because they don't have the same base. So I have to leave the variables exactly how they were, x squared, y to the 8th, and that's in simplest form. So remember, something is in simplest form when you cannot simplify any further, or you cannot combine any more like terms. All right, let's take a peek at algebra tiles. So here we have adding as well as multiplying. X plus x equals 2x, whereas x times x equals x squared. So you're going to be using an area map, which will look something like this. You'll have kind of a T cross. You put one thing you're multiplying on one side and the other thing you're multiplying on this side. So remember that the long rectangles, those are x's, and I have my key as shaded is positive. So the top is positive and the side is going to be negative. So on the top I have 3 x's, so it's 3x. And on the side, left hand side, I have negative 1x or negative x. Those are both the same thing. So what I will be showing you is actually just multiplying those things. What is negative 1x times 3x? So of course by now we should be able to do that without the tiles, so let's show it with the tiles. So it's simply an area map, which means that I take the side length of one thing and multiply it by the other one. So what fits perfectly in here is actually going to be an x squared tile. And that makes sense because when I multiply an x by an x, I should get x squared. I should line them up a little bit straighter than I am now so that it fits right directly underneath. So x times x is going to be an x squared, and then the last thing that you have to take into account is whether it's going to be positive or negative. So for this you're just going to use your basic multiplying rules. A negative times a negative is positive, a negative times a positive is negative, and a positive times a positive is positive. So here for my first, I am multiplying negative times a positive, which means my answer is going to be negative, so I'm going to leave it unshaded. For my second one, I'm multiplying a positive by a negative again, so that one's also going to be negative. And then for my last one, I'm multiplying a positive by a negative, so it's also going to be negative. So now what I have inside is my answer. When I multiply negative 1x times 3x, my answer is negative 3x squareds. I have an x squared here, a negative x squared here, and a negative x squared here. So I have 3x squareds. All right, let's look at another example. All right, let's try this one here. Oh, wait. This is a trick question. You can't multiply anything that has x squareds with algebra tiles. So this one you cannot do. Only can do x's and 1's. Alright, let's try this example here. We have x squared times 2x squared. Well, what did I just tell you? I just told you that we can only do x's and 1's. And I have an x squared, so no, I cannot do this. And the reason is because it would have to go into the third dimension. Algebra tiles only show 2 dimensions. So no, because x squared times x is third dimension. Which would mean we would need a whole bunch of cubes, and that would really complicate things. I do want to try one more example with you. I want you to multiply 3x